Hello everyone. This is the next video of analysis of beam with point load and uniform distributed load. I take this example from Google and I source it and got this one as an example. This is only for learning purpose. This is not for any business purpose. Okay. I'll show you how we can analyze this beam in ETABS. Okay, let's start. I have already defined this in my previous video. Okay, I will start it direct. After that, I will take a blank grid, and this is what we get. And then after, you need to change the unit into matrix as a default. Okay, and you can take any elevation. Like, I think there's no any elevation. Okay, and now I'm going to draw it like uh, at the x direction. I'm going to plot 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and okay, let's do it. Edit grid and story and modify also grid in next direction. Then I'm going to plot at 5, 1, 2, 3, 4, 5. In y direction I need only one grid. First grid is ACDB. ACDB. Just I'll give one name HA and its distance was 3 meter. Okay. It it was C dB C D. We don't need last one. Okay, next we have is 2 meter, 2 and 1 meter. Okay, it's 2 meter and this one is 1 meter. And last, we don't need to place the value B. It's not in the. It do not have any distance from there. Okay, after this all we have is showing like 20 kilonewton. I don't know what is going like 20 kilonewton. I have no idea. Oh, it's 20 kilonewton. I don't know. Okay, let's do it. Uh, After we defined it, uh,
This festive season.
sorry, mm, to add it. Okay, we have our grid here. See, elevation somewhere like A. No, no, no. What is this? This is our grid. Okay, let's draw it. I do not need this one. Let's draw beam here. Okay, from here to here, here to. Let's see. So it's like single beam. Okay, I'll just delete it and it is whole beam is here to, yeah, these are our beam. Then after we need to assign the support like we need to assign, here is assign uh, mm, frame load and sorry, we are going to summon join restraint. Then we have the in support here, apply. Then okay, we have got in support here. Then this portion we have roller support, assign, join, restrain, and roller support, apply it. Okay, this is what we have. Now we have a load 20 kilometer from A to C. Okay, from A to C, we have 20 kilometer. Okay, select this frame, assign frame load, it's a distribution load, and I have already told it where I'm going to use the absolute directs from into one. From this point 0, I have to load 20 kilonewton, and at the distance 3 meter, you can see it up to its 3 meter. It is showing 20 kilometer per 20 kilonewton. Yes. Absolute if it is uniform load, you can click here to all the beam, but it's some part only. We have got some up to only 3 meter. Okay, apply it. We go to 20 kilometer. Okay, now we have another 30 kilometer at a distance 5 meter. Okay, then assign frame load point at a distance. I'm going to use absolute distance from indi. I have given all information about it already in my previous video. What is it? And it is at 5 meter. Okay, in the 5 meter, just right here 5 meter, we can put I have 30 kilometer. I have 30 kilonewton. Then apply it. Oh, sorry, I'm going to select the object, so I will select this one. I will select, apply it, and okay. This is how our object is now. After that, we are going to check our model is fine or not. Then go to analyze it, then check model and select all. Okay, we'll see there is no anyone will message. Then we'll run the analysis. Click here on analysis and give it name simply support. Put it with went and UDL load. Okay, save it and let's see how the result will be there. Okay, and this is our deflection, and this is nothing error message. Okay, let's see first our reaction. Okay, reaction force. It is in FZ points. Apply. Okay, 54.13, 44.13. It is in 50 and 40. Why is bigger value? Because it's considering its own load. So I'll remove its load, self-weight load. Okay. Assign frame property modify. It's showing the mass weight. And it's right 0 and weight 0. And apply it and okay and run it. Analysis next time. Let's see. Just I want to look the value. It's going downward. Deflection. Let's check the value. Apply. Okay, it's 40 and 50. 1040 here. All right. Now we're going to check the shear force diagram. So frame apply and okay. It's minus 40 and minus 50 minus 40. Let's see the diagrams. 50. Yes. We have got same result. 50 kilometer. It's the based on assumption. It assumes that upward will be like positive going clockwise, but its assumption is just opposite. So you can see it's positive. Okay, let's see the mm, movement diagram. Movement diagram. Okay, okay, click it. It's going downward 61.728 port. Yeah, we got exact value 60, but it's exact value 60. Yeah, if you click on here and you can right click on, then we can see our value. Look, maximum movement 61.72 Newton at 2.222, and movement shear force at minus 50 kilometer is at 0 meter for this dead load. By this way, we can draw our beam uh, shear force drive shear force diagram, mo- bending moment diagrams, and load equivalent load on this support. Thanks for watching. Thank you so much. Thank you.